Here, I didn't say that you wouldn't want to work. I'm not sure like how it is was generated, but it looks like someone in class doesn't want to work. And then their teams later feel it and put it here. Anyway. So what we have just seen is it's translating this human language to text. So that's what NLP is. It's part of machine learning and AI. And in the morning, I attended one seminar hosted by Bloomberg, and where like heads of these investment companies were talking about these future technologies. And then what they mentioned about is there's something like AI and ML. Anyway, and then also this AWS reInvent, so which is the biggest seminar hosted by AWS. And I watched all those recordings, and the trend was big data and how to process those big data and get insights. So that's one of the things I noticed from the conference. And AWS has a bunch of data analytical services, and they all are serverless. Okay, that's one main point from the conference. And the second thing they talked about is event-driven architecture. So today we will be talking about that event-driven architecture. Okay, so in order to oh, this is not that slide. To touch that point, we have to discuss some. In order to get at this what event-driven architecture is, I need to touch on these topics first, and then in the end, I will tell you what that is. Okay. Okay. Let's start. Okay. Today we will talk about. Okay, the services we will cover, the main services we will cover is SNS and SQS. So these are application integration services, and I will deep dive into this and application integration services, like why they are there and what benefits it provides. Before getting at this point, I also need to talk about these different models of messaging, how two applications, two microservices communicate, how they send and receive messages one another. I will start with the basic. Let's start with the basic model. You have application A and B, and you want to send message. What you do is you call application B from application A. For example, you have your database and you have your backend application, and you create database client, and then you call it from your application. You did this at your work or in school, right? The directly calling. So that's what this request response model is. And then I highlighted sync in here. It's synchronous. Advantage, there is an advantage that it's very simple. Everyone knows that. Everyone knows like this model. When they connect two things, they use this first. It's naive and it's straightforward. So it's something probably you did. There are disadvantages. So main disadvantage is, let's say now your database is down. In that case, when you send request to your backend, you return 500. it's a try catch block. In the try, you make call to your database, and there is an error, and you catch that error and send error response 500. And in terms of business perspective, that's bad, very bad. For example, the company I work with for Sterling, we receive order through integration platform, like thousands of orders every minute. And if I have that 500 errors, that means you are losing that thousands of orders. And each order costs about $50, I would say. So 50 multiplied by 1,000. So when it's like unavailable for 1 minute, you will lose like $1,000, right? So something like that. So because of that reason, like you need to make sure that your application is fault tolerant. In business, 500 error, it costs money. Okay? It reduces business revenue. So that's the issue with this model. And there is a better model that based on this real world, like how things work in real life. So that's exactly what Amazon CTO talked about this recording. So check this out, and not only that, like in general, in software engineering, there are some effective, powerful patterns. Those are popular and works best, and those are derived from real life patterns in nature, in real life. Do you agree with this statement? You want to solve something, and they do this based on real life events. So all things in this world, what he mentioned is like all things in this world, it's asynchronous. So then what I'm suggesting is let's change this synchronous requested response model. Let's make it asynchronous, and let's see what benefits it brings. We are making it more like real life. And then what happens is that, so after following this, how the nature works, it reduces latency. I'll elaborate on these 3 points again. For now, it reduces latency, and your fault tolerance is increased. Now you're not returning 500, you are returning 200 success. And also throughput is increased on the consumer side, or in our case, consumer means the application B who's receiving the response. Okay, so these are the benefits that asynchrony brings. And how can we make this simple synchronous request response model asynchronous? And the reason how we can make it asynchronous is using something like queue. Now we had 2 components. Now let's introduce the third component in the middle, such as a queue. And everyone knows what queue is. It's something you put the message and you read it. Okay, and then there are some technologies. So this pattern was there even without cloud. So for example, ActiveMQ that people used even before the cloud, because they know that making this application communication asynchronous brings these features. So it was there, and in AWS we could use services like SNS SQS. And when we do that, now your request response model is point-to-point model. Again, asynchronous, it leads to, so from this talk, it leads to loosely coupled or decoupled applications. The decoupled applications are desired because those are evolvable. Evolvable means like you have an application and you have new requirements that you can implement. Like you can add new features. In monolith applications, like it gets harder. As application grows, its complexity is added, and then it gets harder to add new features and even maintain it. Evolve means it's like application that you can add new features, and this is the application that we desire, like about all the business desire. You want to add new features, and you can do it. So, for example, the evolvable application, what they mean is, like as an example, it's Amazon S3. When they first released S3 service, there were only 8 microservices in like 2010 something years ago, and then now over the last decade, they added new features, and it was possible because their application was closely coupled, evaluable, and you can also take a look at the slide in the S3 lesson 2, I think, or 2-3. There's design pattern. So that's how they built this powerful service. And now there are like 280 plus microservices here. And there are many features. It's possible because it's available, because it's loosely coupled, because it's asynchronous. This is how it looks like. Simple request and response model. You have application A and application B. Oh, this is supposed to be B, so I'm gonna end it. Application A and B, and this is straightforward. And now point to point or asynchronous model is this. You introduced Q or SNS or SQS in between. Okay, so let me show you something here. Yes.
Could you hide the bar at the top?
Sure. I'm not sure if I can. Okay. Okay, let's elaborate more on this model. So first one is clear, right? It's just component A and B. The second model, the point-to-point model, is something we are interested in. So I'll call it like application A or microservice 1, or just you call it like it's application A, and they are sending message to a queue, for example. Queue is message storage. So application A, they send message to the queue, and application B, they listen to this queue. They listen to this queue, and if there is a message, then they will pull that message from this queue. Okay, that's one thing. There is a bunch of main points here. The first main point is, as I mentioned, it's pull model, because consumer is application B is pulling. In this case, A is producer and B is consumer. Okay, one thing to keep in mind. Second thing is, so now I talked about latency. So let's say that storing this A and B, so for example, storing data in a relational database, it takes longer time compared to NoSQL databases. It takes 3-digit millisecond, let's say like 13 milliseconds. Okay. If it's NoSQL, if you use DynamoDB instead of relational database, then you can reduce your database latency, read and write latency, from 3-digit millisecond to 2-digit millisecond. Okay, so that's big difference. So this is an example. This is like what happened at my last work. So at my last work, we had this latency. We used Amazon Aurora, and then our backend is Java application. So it takes 3-digit millisecond. And we wanted to improve this database writing, this operation. Like we wanted to reduce the latency. And as we mentioned, we can use this. If we use Q, then we learn that it can reduce. And now I'll tell you how. Now notice here, you are sending the same message from application A to B, same message, but writing to Q, such as SNS, it takes 10 milliseconds. And then it returns the response immediately. So first, it sends the message to the queue. Secondly, it receives the response. So that's what your client app is calling. So it's making a request which takes 210 milliseconds, and then it returns response, and then here. And then the tag in general it took 210 milliseconds. Whereas in this case, your client is calling this application, which took only 10 milliseconds. Compared to this, it took 210 milliseconds. Just with these mock numbers, you see that you made your application, specifically this operation, 20 times more performant than the previous version, 21 times. You follow this? You receive it. Okay, follow. Very good. Okay, that's the main point. And then how you process this message, this payload. So this is message that let's say we want to store it in database. This process and this logic is it's up to the consumer. The producer, it doesn't care. It's known as fire and forget. Just fire and forget. It doesn't matter how these consumers process. Okay, that's here. So consumer is fire and forget. Fire and forget model. And that means consumer is consumer processes. And producer like doesn't care. Producer doesn't care. Okay, you have the idea here. So it's in this style. That's one thing. Third point. So it's point-to-point model. As its name suggests, it's one-to-one relation. One-to-one relation. That means the application is sending this message to a queue, and you might have multiple instances of this application B. This application B is running on multiple EC2 hosts. In that case, only one of them will process the message. That's what this model is. This point-to-point message one-to-one processed by this. That's pretty much all, like some designs here. So now you might be wondering that, so this is the third, like application level. You might be wondering what will happen if there is an error with this message. Like this application, like this producer, they receive the request, send message to the queue, and then they return success. And then consumer tried to process this message, but there is something wrong with the message. In that case, like you have already sent acknowledge. It's not like a response. You have to think of this as an acknowledge that it received the message. But you already sent 200. So now how do you send your response back? So for that, what you can do is you can simply, like in case of error, so it could be successful. Maybe it's storing that in the database. And this is fourth step and 4.1. It's successful. But what will happen if it's the second edge case, that there is an error in here? In that case, what will happen is you can simply push that message to another queue, or in AWS they call it dead letter queue. And then just now in this queue, you will see those faded messages. And then it's up to you that how you process is up to you. Maybe someone from support team, they can process this messages manually. Or you can write another application that is with this faded messages. So like that, if the message is faded, then put it to another queue and then move. Does that make sense? Yes.
This probably is stored in what queue, right?
Yes.
And what of the response from B is going to be different queue. So A is choosing from a different queue.
Okay. B doesn't return any response because so you have already returned the response as soon as you push that message to the queue. The response is already sent. Think this. I understand it's like hard in the beginning because we do things we're caught in with this synchronous mindset, but like you need to shift this mindset in this model, and now how you change, like just change your mindset completely. Like in this model, you receive the message, you send the response, and then processing this processing and done asynchronously. It's different logic, like it's not traditional way that you return response as like immediately. It's synchronous, like it's done in.
When the asynchronous goes back to A.
It never goes back to A. It would go like it would be successful. For example, this your data is stored in database. Let's say that's what you wanted to do. What you wanted to do is like store a message in database. B, there are two things, like this operation could be done successfully, let's say start in database, or unsuccessful. In that case, like have different logic. Yes.
If the message is unsuccessful, then what customer is this? If there's an error.
Then yes, then like this support guy can email to that customer, or you can write this application that in this application can send message to the customer, like it's failed.
Draw arrow back to the head brings the queue, right?
Yes. Yes.
Event is received in the queue.
Yes.
Response, okay. Our successful message back to the head.
Yes, that's correct. Like you send message from application A to the queue, and then queue returns success 200 response. That's what you receive on the client side. And the client means I mean this producer. Period. Who doesn't fail? It's so in our case, it's an SQL service. It never fails. And by the way, you might be wondering like how many messages it can handle. I think that okay, the first one I read this, I think it's, so I'm going to the like point number 3 that I said talked about throughput. So SQS, it's fully managed by AWS. It will always be available. It would never go down. Without cloud, we used ActiveMQ. In that case, like we have to manage our ActiveMQ cluster, and that on us, and we might make mistakes that could lead that to downtime. But with AWS SQS, it doesn't fail. And number of messages it can send is, how many do you think? It's unlimited. So you can set unlimited number of messages to this queue. It's fully managed by AWS, and also it doesn't cost anything. It doesn't cost, and it can deal with unlimited number of messages. Anyway, so I think that answers this question. Since I touched on this throughput, okay, I need to draw this diagram again. Yeah, another issue with, okay, I'm using this red color now. I just talked about is I iterated on this lower latency. And now what I'm talking about is this throughput management. And then for throughput management, I'm using this red color. So let's discuss about that. It happens a lot. It happens a lot. With this resistance approach, what happens, let's say that your application can handle 1,000 messages because at a time. Unfortunately, your, let's say this application B or database can handle 100 requests at a time. If you send 1,000 requests to be processed by this application B, then what will happen is there could be two things. So maybe your B will go down. B will go down because there are too many transactions. Or if you can handle this, you like instead of failing it, it's something like try catch, so you capture the data. Then best case, worst case scenario, if B will go down, it happens a lot in real life applications, or 900 requests face, right? You're bursting your application, sending 1,000 requests at a time. And then in this case, this could happen. So that's what throughput is, like throughput. And this making this asynchronous, this queue can help you with this throughput. So basically now with this queue, again, this application says, as usual, it can handle 1,000 requests at a time. On this queue, is unlimited number of messages, so we don't have any issues in here. And then it can store, you can send unlimited number of messages, and it can store unlimited number of messages. And this application B, it's pulling message from this queue. So it can pull messages by batch, like 1,000 message, 100 message from this queue. So application B basically pull message 100 by 100. In this case now, the 900 requests will stay in the queue, and it would be 100. And then after processing this 100, it will pull again 100, and now this number is decreased to 800, and then 700, 500, and then you can deal with bursts. That's what this throughput management is. So now, in this case, notice you are processing all the messages without any failures, because you defined this throughput in here. Makes sense. Very good. Last point, better fault tolerance. That's maybe here. It's similar to this throughput. Let's say this, if this application is down, then you would return 500 errors. So that's bad. And in this case, even if B is not functioning, your messages are accumulated in this queue. Right? So 100, 200, 300, doesn't matter. It can store this message. It can store unlimited number of messages for up to 2 weeks in case of SQS. Like 2 weeks. So then, like when your application B is offline, it's okay. Like you are not losing any data. You already returned 200 to your clients. Your message is there in the queue. Like you can process it asynchronously later on when the application B is back online. And now after 2 minutes, it's back, and then it will start pulling messages and start processing this. Without this queue, like you were returning 500, but now you are not losing any transactions. Again, from business perspective, this is money. One transaction is, and that's exactly what we did at my last job. One of the initiatives we did this. Yes.
Was you can do like about 100 right? But how even if we could like would be like the first and first out method.
Very nice. Yes. Based on this queue type, in the SQS, you have two types of queue, standard and first in, first out. If it's first in, first out, then yes, you will get like the first message is processed first. If it's a standard, then you might have, like you can try to order it, but we will deep dive into that. I want to iterate once again on this fault tolerance. It's something we did at work and scroll all the way down. So there is again, design pattern called circuit breaker. That's exactly what I explained a few moments ago. So basically, it's used to detect failures and encapsulates the logic of preventing a failure from constantly recurring during maintenance or temporary external system failure or unexpected system difficulties. So basically, it detects that application B is down. So it's a tool that tells you that message. For example, if database is not available, then instead of trying to keep inserting that records, you can just, you already know like it's down. So you don't have to send that message. Instead, like store it somewhere, something. Okay, so this is how it looks like. So for example, circuit breaker design. So there are these three states. If circuit is closed, that means underlying system is working. All transactions are success. So it will send message from A to B. It's all success. Whereas if application B is down, then it will know it, and circuit state is changed from closed to open. That means it will not send any message to application B, or for example, like whatever system that's down. It will not send because there's no point sending it because it's down, right? You don't have to send over and over again. And then once the state is open, then it will check if the service is back online. It's like it will do those health check calls, the health check call that Cloud Balancer make against EC2. It's sent, and then that's what health open state is. It sends some requests to the underlying system to see if it's back or not. Just elaborate on this, and then Java. We had Java application, and then we had database. And then basically we implemented the circuit breaker design in our application. But for that, we used this resilience4j library. So that's what this, how you can implement this in Java. And then if circuit is open, the underlying system is down, then we send messages to queue instead of the system that failed. Yeah, that's, I think,
Can we have the acquisition subscribe feature in SQS? Because
very good point. Yes, SQSs in AWS services, they focused on one functionality. This SQS, it's for this point-to-point model. So one consumer, one producer. For that, you use different service SNS. SNS is for publish and subscribe. Okay. So what he is asking is, that's our next topic. So this is here again. We are not there yet. Okay, we will cover it, which is the short answer is SNS can do the subscription. What we are discussing right now is point-to-point model. So we have discussed only two topics: request and response model and point-to-point model. So I will get to there, but point-to-point model, as its name suggests, just send to one, not many. Okay, not many. Okay, this is about Q. So application A, sending message, wanna send message to multiple applications, as he mentioned, like B, multiple subscribers or applications, doesn't matter. B, C.
It's a different thing.
Different? Oh, sure. Okay, I'll go back to this topic again as he asked it. I will just elaborate because it's we will cover it in a few minutes after a couple of hours. So basically, application A, what he is asking is sending message to different application B, C, D, E, right? So you ask like if it's possible in SQS. SQS is it's not possible because it's point-to-point model. It's one-on-one relation. And this is known as fan-out. We call it fan-out. In messaging world, we call this fan-out. And what it does is there is a message in here. So your client application submits one message in here that's sent to the subscribers at the same time simultaneously. Okay. But we don't directly send message this way. Like this now it's notice here it's similar to the model, similar to traditional request and response model. Like we need something in between. Like we use it queue. For this one, we still need something in between. So that's what. So we need something in between. That's what SNS is. That's what event bridge is. So basically, we need something. Like we compared the synchronous model with asynchronous, and we know that like asynchronous has lots of benefits. Those 3 benefits. So let's just make it asynchronous. And we call this something in the middle. So this is SNS. More specifically, this is what we call this. Do you remember? Yeah, I'm just SNS. More specifically, it's topic, right? We create topic, and then we subscribe to it, and that sends message to all. And yeah, event bridge. In event bridge is like updated version of SNS. They do the same thing. Event bridge has more features, more enterprise features. Yes, event bridge is the exact same thing. Event bridge. And more specifically, we call this guy in event bridge called bus, message bus. You send message, and this is a bus. And if there are subscribers to this bus or topic, then it will send that message at the same time. You might want to hear some real-life examples, right? Real-life examples. So this could be handy in real life. For example, okay, let's put it something. So something it's topic or event bus. And we have, let's say, our client application, and it's storing some data. So it's going to be payload. Okay. So it's just storing something, some entity, maybe you say anything. And you send it to this. Let's say you send that to event bridge bus. Event bridge bus, let's say event bridge. Event bridge. So first thing you do with this payload is store it in database. RDS. or DynamoDB, like NoSQL database. It's what we always do. But there is an issue with this RDS and NoSQL database when it comes to searching. Where your table, let's say, has 10 columns, and if you want to look by something like first name, last name, it scans every single record unless you set an index. That's how it works, right? In RDS, it's like when you do select star from table and where column equals first name equals to something. So it takes O time. Searching takes O time. Unless it's a key. Like if it's a primary key, then it's O. You can improve it by setting index. So for that, let's set index by first name. So now it can search faster. That's what O log n. And then searching by key is O1. But there is an issue with this index. You cannot set index to every single field. So that would increase your cost because an index under there would like forms one table. If you have one index, you double the cost. If you have two index, you would pay 3 times more than one table. So because of that reason, like for transactional search, it's transactional create, update, read. Have you ever heard of technologies like Elasticsearch or so we use something like Elasticsearch for improving our application. Like we want to improve the searching for our transaction application. So we use this Elasticsearch. And I think they changed this name to OpenSearch. OpenSearch. So basically this is full text search that helps you with searching your data. So basically what you can do is maybe from your database, you can enable like binlog as we discussed yesterday and then send it to Elasticsearch. Or you can do it in the first place with this event bridge. So first it stores that payload to this database. Secondly, you might need to search on this field. So for that, you also might need to send that to this thing. Also, you probably need to send this message to company's centralized data warehouse or data source. Data warehouse. Or now we call it data lake. And data lake is essentially its S3 bucket. So you might want to store this payload for analytical reasons. So this is like 3 reasons that I can think of when there is a new record. You want to store it in database. You may want to send that data to OpenSearch, or you may want to data lake. So you want to do this like at the same time. In that case, that's when this comes into the picture, I guess. Yes. Like, there are like these 3 like use cases that you have a payload and you want to send that message to different applications at the same time. Okay, let's take 10-minute break, and after that we will see what is on this slide and something else. And come down to me here so I can hear you better.
Yeah.
First thing is, like, I appreciate how you approach this, how you approach, you want to study this, like the way you study, I like it. Like a cool student.
Because there's no investing now not in the actually the background, you can clearly understand the picture, so the concept.
Sure. Here, yeah, here is just some simple examples. So in real life, like there are like many applications at one, and then we have no idea what that does. But then, yeah, this is
If you get a failure when sorry one page and everyone a point of three, the functionality is when the concept is when we do the API, we do for example we separate the transaction for example right to the database. Yes, this one is only for searching.
yeah for searching. Yes. Analytical.
The purpose for this will perform the processing to write the data. Yes, the database and this processing and for if you want to know anything, we can store in the database.
Yes. All at the same time. Like here, the traditional way is we write ETL to export this data to here. But with this event-driven architecture using this powerful services, now you don't need any ETL. You can just send the same payload at the same time. It's messaging payload. Sure.
Messaging system. So if we use it in the real world, for example, like you say that API, for example, the consumer, it will respond in its convenience. You say that. So if in the real time applications as this help, for example, order a pizza. Okay. So or is it there are some certain kinds of applications on your system because it is confusing, you know? Like if I order pizza, for example, somebody else, and then if the application sends success, and if it responses after 1 day, or how does it work? I am confused.
I agree with that.
Yeah.
I noticed how this modern applications work. I noticed it, and I noticed like those ordering systems, or like some of these big platforms like Google or Facebook. I noticed that they looks like asynchronous. They give you the response, and then you add, for example, you add something, create a new record, and you see that record like after one refresh, because they do it asynchronously. And his ordering those systems again. I don't know all those details, but I'm sure that they might be doing this asynchronous. But I would, what I can tell
I
you
think
is
maybe for
okay.
those kind of systems, it should be
Okay,
different.
how you can learn more about this is using here's how I do it.
Yeah, it makes sense what you said about
Medium.com. Here people share their real life experience, and I see like one similar example, like Lego.com. It's a big application, and their architecture is using what we discussed, using this event-driven architecture, and then this, and then that same architecture, like ordering application. Like when it comes to like this complex ordering, even this Amazon Web Services, they are doing also this asynchronous step. And then here I can give you the link. So
yeah, I'm just thinking maybe it works like that.
it's good. Even people do that way. They don't do the synchronous, they use asynchronous. Even Amazon website ordering. But notice that when you order, it's done asynchronous.
Asynchronous means the one that you said, the new one. event.
Asynchronous means like you receive the response immediately, but once you place an order on Amazon, let's say, there are like so many things going on.
Yeah.
So for example, discount, promotion, shipping, payment, auditing, you name it, right? When you just hit one, there are way too many things. And some of the operation must be done asynchronously. Even in Amazon,
So it means it's going through the same thing you said, like the.
yes, like
events.
idea is there. Yeah, I don't know, like,
Okay,
like
I have
the,
to
yeah,
check.
the patterns they are using is asynchronous. Okay, one second. Yeah, what I was, this is my favorite.
Oh, you have also Medium.
I don't write, I just use it for reading purpose. There's some, yeah, this is, check out this guy, and this is, I think he is a tech lead at Lego, and if you read his blog,
Okay.
this is how it looks. You got the idea, right? This is how it looks. It's super complex. They got this application up and running because they embraced, and now in his blog, if you look at here, like he explained this in more detail, like how they implemented ordering system in this event-driven architecture. Like,
It's interesting. I can read this one. And what was the other one? Logo.
no, just stick with this one. There is a lot of red side.
That's the other
Yeah.
website. Logo. What was that?
Oh,
Go on,
No, no.
like that.
just ignore that.
Sending it is what
I will send you this one. Yeah. Maybe
I'm sure.
okay. I can share it here on this channel. Okay, I put something. So at they use this event driven architecture, and here you can see more details how they do it.
Okay, yeah, I can read. So even you think the pizza could be done?
Yes, Villa is like something with something like
I
that.
think so.
Yeah, it,
I
like,
can ask you.
sure.
Yeah, from just you just draw. There is a phone here. And then it sends the message to the queue. And you say it's immediately this was.
Yes.
200.
Yeah, 200. Yeah, immediately.
Yeah, it means like, but it doesn't know whether B.
It's for the successful they are.
Yes.
Yeah.
How's that possible? And also, how, in what way does B will return its response to the client? What's the link?
The first thing is A, fire and forget. Send a message, put it to a queue, return response. In short answer is this guy will not know unless you send the response again to this client explicitly in your application. And okay, I know that it sounds odd in the beginning, but this oddness brings some benefits. We can like those three benefits I discussed. For that reason, you do this, and then you know this, right? Dead letter queue. If there's an error, it will go to dead letter queue. And then you can, yeah, if it's successful, it's success. Then you don't even need to return the response because you already returned success in here, right?
Yeah, right, but okay.
In case of error, you can put that message to different queue, and you can have another application processing this message, and this application can then respond back to here. After success, maybe. Oh, I'm sorry, it wasn't success, so it failed.
In the database, what if there it's another application and it has to return a response around
like complete
Yes,
response to the plan. So instead of 200 message, what if it is 100?
very nice press. That happens. I'm sure like that's how the real life applications look like. They have this chain of applications. What they do is when there is a request in here, you generate one correlation ID, one ID that you can track on all these components. Does that make sense? Request number one, and it went to F8 successfully. It went to FP successfully, but it failed on FT, or it failed on FD. So that's how you can track your record. You need one correlation ID. And then by looking at that, like you can see where the request failed, and then you can do your process. Correlation is client doesn't care, right? Again, it depends what you mean. It's like depends on this. This is how literal. Now I think you got some picture of it, like how it's like many pieces scattered in the cloud and many people. And I would like in this today's stuff, I will talk about the function I demo it. In that case, you can see how can orchestrate this minute.
I'm really interested in.
What kind of, I also want to. What you need to perform?
I think it's better to pull it. I think this is better
Sure.
than the other. Thank you.
Professor, did you post it?
Yes, I think. I did it. Okay, during the break, I received 2 questions from 2 students, and they were very good questions, and I answered to them. The first question I received is like when it comes to ordering system, I don't think you can send return asynchronously, like send 200, because you ordered something, and then after an hour you receive that. Yeah, you reject, but then you are so hungry. So, and then these students like wondered if you can do this in ordering system. Basically, that's how I interpret it. And so this, I noticed these real life applications like Amazon or notice these big applications they were adopted by these giants. And I noticed it's asynchronous. I start something, and then I don't see the response immediately, but I receive the response after like 1 second, 2 seconds. But this looks like and then answer to his question is yes. I am so sure that ordering system uses this asynchronous. They embrace this asynchrony, and they're using it for sure. And then I read these real life examples on medium.com. I read Medium, and where I like, so this is post I just shared on Teams here. So he is a developer, like he the architect at Lego.com. Lego is the biggest, like they have this hundreds, thousands of requests at the time. And this is this writer, he wrote how they do their ordering application using this event-driven AWS stack. And see here, notice here, it's just one of the APIs at Lego. Take a look at this, like take 5 seconds to look at this. There are many things going on. When there is loyalty, there are like many actions you have to perform. When it comes to ordering, you also have many actions to perform. If you do this in a synchronous way, you have to wait like 5 minutes or like, and then the technologies you are using is, for example, if you use API gateway, the maximum timeout is like 29 seconds. Like after 29 seconds, it terminates the request. It times out. Like even these technologies requires you to keep latency low. And then when doing this many actions, your latency would get increased. So I'm sure they are making some of them asynchronous. And then like check this blog and visit his page and check his slides where he explains like in more detail order validation, order data storage. Okay, so that was first question. And the second question is, again, it's a very good question that. So currently we only have two applications, application A and B. What if there is something instead of database? Instead of database, in real life, you have just seen that image. You have a lot of applications, C, E, and so on. We never know. And then maybe this BC, they connected with Q, or they connected with SNS, or they connected with Eventbrite. Like there are so many components. And now you this client sent one request, and that one request goes to this model A to B, A to B, B to C, C to D. And now, like, how do you track that? So B is fine, but the order could fail on the component C or component D. Like, so for that reason, how you can track it is, it can get tricky. Yeah, I agree. And then what people do is they create something called correlation ID. So they generate something like correlation ID. So now your request has correlation ID 1. And then in that correlation ID, with that ID, you can track like, okay, transaction from A to B was success, but transaction from B to C was success. But unfortunately, it failed transaction from C to D. And you can see those transaction lists with that correlation ID. So basically you can, with this request, you can give correlation ID and then you can send a response back, like how you can track. So something like okay, let's see what we have in this slide. Okay, this point-to-point model, there are some disadvantages that is like returning the response. So currently we just receive the acknowledge, we return 200. But what if there are many components and if that's again, you might need this correlation ID. And so here, the producer, when you have this point-to-point model, and you might wanna do, so this point-to model, you might, like you wanna implement something like this. Like you have Q and you wanna consume it from many applications. Like this point-to-point is one-on-one. If you wanna add like C with this Q, then it can get tricky because its model is designed for one-on-one. It's not that evolvable. Like you cannot add, you can add it, but your code gets complex. That's what it's trying to say. So what it's trying to say is, you want to add new modules. You want to add new modules, but then this Q is one-on-one model, and you can do that, but your code gets tricky. So in that case, you want to have a queue and multiple applications. It's better to use this next approach, this event bridge. And okay, we're going into the asynchronous method. You can have to handle this error. So we discussed about that. You can dead letter queue, and this is how it can be. Like application A sending message, and B produce here. If there's a message, it will send it to queue, dead letter queue, and then another application. Okay. So event path model. So this is something what we discussed in here. This here. Notice here, everyone. Notice here. This guy. You send message to this topic. Application is send message to the topic, and then this SNS. This pushes that message to all the consumers at the same time. notice that this arrow is pointing to the applications where B is pointing to the queue. So one is pull, the other one is push. Okay, and in point-to-point model, as its name suggests, it's one-on-one. If you want to add more applications to that queue, if you want to add more consumers, like your code gets complex. So for that reason, to simplify this, you can use this asynchronous event path model. And here, point-to-point model, one message is processed by one consumer, whereas in the event path model, that message is sent to all the consumers at the same time. Okay, so that's about this like design pattern, this different models. Introduction. Now let's deep dive into this each service like SQS. It's implementation of that point-to-point model. SQS offers a secure, durable, and available hosted queues. It lets you integrate and decouple applications, and it provides both SQS provides unlimited scalability, and there are two types of queues: standard and FIFO. Standard queue, use it when you need, like when throughput is important. And the standard queue provides nearly unlimited number of API calls. To send a message, you make API call, and that's nearly unlimited. And it makes sure that your message is processed once, at least once. But occasionally you might get duplicate messages. And then it tries to order the message, but occasionally maybe it's not in order. So for example, here, this message 4, 3, 3, so there is a duplicate in here. And then somehow 5 in here. It tried to order it, but 5 in here occasionally, and then 2 and 1. When consistency is important in your application, then you can use FIFO, but there is always trade-off that now you lose that nearly unlimited throughput. And this currently consistency and this strict message ordering. So it provides high throughput. It's not unlimited, but high throughput. And you can send up to 3,000 messages per second. So it makes sure that messages processed once. But I don't think it's a big deal, because in your application, you can implement the logic to handle it with duplicates. You can have ID, and then, but this is not. First, and then it makes sure that all messages in order. So now this time 1, 2, 3, 4, 5. There's no duplicate, and all are strictly ordered. Same thing. And this SNS, SQS, and both services, you do have this FIFO ordering. So there is, yes.
Yeah, that's like,
Okay.
what is batching?
Batching means with one call, you are sending multiple messages. Yes. So for example, here, how you send message in SQS is SQS, you call send message function from this. Okay, in send message function, you provide the message. Messages that say A. And then instead of sending a string, only one message, you can provide an array of strings with 10 elements, up to 10 elements. And now you are sending 10 messages in that one API call, one function. That's what batching is. Batching is like, it's in one operation, there are many data.
For point number 2, exactly one person. This means one consumer can subscribe to the topic model.
No, this is for FIFO Q. For Q. I noticed there is FIFO SNS topic, but I haven't used this. I haven't used that before. But here is what we are discussing. We are just talking about Q, not SNS. Okay, this is image expression. Okay, so there is something called message deduplication ID in when you have this before Q. So that makes sure it's the message is processed once. Let's go to SQS. And the best way to learn this deduplication ID, and you can learn the deduplication ID by playing with this AWS console. So I'll show it to you. I'll create two queues, standard queue, and my standard. So you have two options. So here, take time to take a look at this wizard. So it's at least once, and message ordering is not preserved, and that's this one, delivery and best ordering. If you select this, it would make sure that message is processed once, exactly once, and then first and first out. Anyway, let's give it a name and create this. When you create, this is standard queue. Okay, I'll create another queue, another FIFO queue. So for FIFO queue, here, select this, and you have to have this my FIFO queue dot FIFO. You have to have this suffix create. In the standard queue, it's okay. Click on the queue, and then you will see this send and receive message. This is how you can play with this. So currently, we don't have any producer and consumer applications, but still we can use this UI to send message. So this is my message. Send it to this queue, and if you scroll down, you will see these poll messages. And now it's polling message for how many seconds? It's like polling here. So you can configure this. I think it was for 30 seconds. Anyway, we see the message here. Expand this, you will see it. By the way, notice here, like you can pass some attributes along with your message for like some metadata. That's what standard queue is. Okay, you send message, you see it. When it comes to FIFO, it's a bit different. So it has these two properties that it makes sure that it's processed exactly once. It does this. It does that with the help with your help. Okay, it do not do that all itself. You have to provide some information to it. Okay? It don't do that automatically. So here, my FIFO message. Okay, if it were a standard queue, it should work. But then, since it's FIFO, it asks you, it requires this two attributes. Okay, group ID group, it's something that you are grouping your message. This logic is all up to you. Maybe you can group by application or module name. I don't know, it's like up to the business logic. And just group with one. This is a message in group one. And let's see what it says. The message group is the tag that specifies that a message belongs to a specific message group. You can call it maybe app1 or app2. So you can do that way. It requires message group ID. Message deduplication ID, they also require this. So it's a token used for deduplication of messages within deduplication interval. Okay, this is too technical. Just from user perspective, let's say that you place it an order on
online, like you place an order, and then they charged you twice. So you will not be happy, right? You want to make sure that when someone places an order, that data is processed exactly once. If it's processed twice, then those kind of cases could happen. So this is basically in a nutshell. You can give it like an ID that makes the message unique. Period. So this like might be the better definition for this. Message identification ID is an ID that makes this message unique. For example, like message ID. They also call it. Okay, I'll tell you later. That's how it looks like. So you need to provide these two messages and send this message. And now you'll see the message in here. And now I changed the message. If I send this message, then what do you think? It will not accept the message, right? Maybe it will show the first message, but the second message we didn't receive. It's still polling because it had the same identification ID. And then it called about like something like deduplication interval. So what is that guy? So let's say by default, I think it's 5 minutes. And if I send this message, again, this 3 send message, it would not accept for 5 minutes. But after 5 minutes, if I do this, perform message after 5 minutes, or it's after deduplication interval. If I keep sending this message for 5 minutes, then when the deduplication interval is run out, then it would accept this new message. This is like message ID that makes sure it's unique. Another thing.
Is it going to override it? To the existing one, to the first method that we use here?
Yes, it will overwrite once this interval, once the deduplication interval run out. When it run out, then it will overwrite the new. Okay. You can do some work around this message identification. It might be handy for processing. For example, you have before message. We already have this message in here, but you want to send. It looks like the same message, but you want to treat them as 2 separate messages, right? It looks like the same message, but you want to treat that as a different message. In that case, like simply provide different deduplication ID. So you have it looks like the same message, but it would have there should be 2 messages now. Same message. So you might need this because maybe the message looks like the same, but the metadata could be different. Like metadata is customer ID equals to 1. So customer 1 sent this message. So now I sent this. Customer 2 sent the message, the same message, but we want to treat that as 2 different messages. So you can do something working on it, or like vice versa. It's different message, but you want to treat them as duplicate message. AST, ZXC, these are 2 different messages, but you want to treat them as 1 message, duplicate message. That you can also do some work on the duplication. Okay, and then you can also enable content-based deduplication. So, oh yeah, this deduplication ID also known as idempotency key. Okay, when in the event-driven architectures like this, so it makes sure that like idempotency potency. So do you know what this guy is? So basically, yes, yes. So for example, idempotency. I can tell it verbally. So you have a function called sum function, like add function that adds two numbers. If you send 1 and 2, you would always receive the same response. That's what this idempotency is. Idempotency. Anyway, group ID we discussed. And group ID might be handy because you have like some limitations. So let's say this is your queue. And in your queue, you have message 1, 2, 3, 4, and so on. And you can have maximum up to 20,000 messages, it looks like. 20,000 messages. I did this a year ago, maybe it's updated, so it's subject to change. And now let's say that there is a bottleneck when processing message 4. There's an issue in here, like it is stuck here. In that case, you cannot process the other messages. So basically your entire queue is not working because there is something wrong with this message number 4. If you have two different two different groups like F1, F2, and even if group 1 is, there is a bottleneck on the group 1, you can still process the other group. And with this group ID, you can also do some parallel processing, as you see here. So there are like some details here. This is again another main topic. So first we learned about the model, point-to-point model. And now we are looking at its implementation, SQS. And point-to-point model, this is general model, and it's like one-to-one. Messages processed by one consumer, not many. That's how this model works. And how SQS does that? So the answer is SQS, this visibility timeout. Okay, so let's go back to here. Okay, I'll just explain it here. And so component 1 or A sending message to a queue. And SQS is a distributed system, and then it makes sure your data is durable and it's highly available, meaning that your data is stored in multiple data sets and many servers. So A is that message is like everywhere in the cloud, like so it's replicated and somewhere in the cloud. And now component 2 is reading the message. Okay, reading the message. And then when the component 2 reads the message, this visibility timeout starts ticking. And during this visibility timeout, as its name suggests, when it starts ticking, it hides these messages. This message is hidden. That would make sure that it will not be consumed by component 3 or component 4, right? Because it's hidden in the queue. Because component 2 pulled this message, so it hides the message from other consumers. So it makes sure that it's point-to-point model. But the thing is, this timeout, SQS is a distributed system, and how this model, this point-to-point model works is it fire and forget. So we never know that if component 2 process this message successfully or not, right? So because of that reason, component 2 must make sure that it should send a response to SQS telling I processed this successfully. And how you send that acknowledge to SQS is you delete the message again. The acceptance message processing acknowledge is delete the message. So it deletes the message from the queue during this message timeout. Notice here, component to and now let's take it here. Component 2 done processing the message in 25 seconds. So they're done with this message. And then they delete this message, acknowledging that they're done processing this message. If this guy do not delete this message, what will happen is after this 40 seconds, message will show up again, and then it will be consumed by another consumer. Does that make sense? At first we talked about high level, and now we're talking about like how it's implemented in SQS. You have a message, again to summarize. Producer send a message, and since SQS is managed service, and to provide durability and high availability, it replicates message on many machines. And when the consumer consumes the message, SQS hides the message. And once consumer done processing the message, it has to delete the message, acknowledging that it's done. Otherwise, message will show up again once the timeout is run out, and then it might be processed by other consumer. So that's the main component in SQS. There's just a few concepts. I think there are like 2 or okay, 2 SQS, like 2 these main points in your mind after this class, after a month. So the first thing is there are 2 types of queues. One is and the second thing is like don't forget how these work, how they hide and show messages, how they make sure the message is consumed by one.
Can we configure how many consumers will pull the same message? If there are 2 services pulling from the same queue, they require the same message A. But I'm not clear if here is step number 2. So there are component 2 and component 3. They need same message A. If component 2 pull the message, A is hidden.
Yes.
What about component 3?
The component 3 also cannot see the message. No one,
Pull the message.
cannot pull the message because it's hidden.
But component 3 requires message A in that scenario.
Requires.
Yeah, what if component 3 also need to process message A at the same time with component 2? Can we configure in SQS?
I don't think that's the use case of SQS because now you are talking about something like fan out. So you wanna process this message A at the same time. That's not SQS does. SQS is like one-to-one relation. If you want to do that, use SNS or event bridge.
Well, we can put SQS for both components.
Yes, you can do that. Then you have to manage like 2 components. And then this event-driven architecture, it's something as I drew here. It could get like, it doesn't go complex, but there are many components. Like it can get to orchestrate all these many components. So that's when the step function comes into the picture, and that
I will show you today. Okay. And yes, as she mentioned, yeah, like if there are two applications and then two queues, one producer, in that case, now you have 5 components, 2 queue, 2 consumer application, and 1 producer. And now you wanna like orchestrate these 5 components. Like you wanna see all these 5, you might want to see. And next concern with this event-driven architecture is how you monitor your application. You wanna see those 5 components in one place, and when you submit a payload, you wanna see how that payload flows real time. That's what the function does, and I will show it to you shortly, Robert. Okay, there's something called short polling and long polling. And short polling, the receive message request queries only some services to find the message, and that is available to include in the response. And SQL sends the response right away, even if the query found no messages. So short and long polling is it queries all the servers and it makes sure that there are at least 1 messages. Okay, to visually see this, you can just simply, it's similar, I would say it's similar to this, it's polling. So currently, I think, okay, stop polling. Like your consumer application, how long it polls. So for example, polling duration, if it's 3 seconds, then just 1, 2, 3, done. So it's short polling. Whereas if you make it 30, then it's long polling. It's polling and polling. So again, this is when you work in the AWS cloud, just keep one thing in mind, that every API call charts, I would say. Like some of them, but when you make any, like most cases, they charge. Okay. So you might, when you work in the cloud, you might want to keep number of API calls low. In that case, which one would you prefer? Long for sure, right? But then let's say that this queue is pretty popular and you have hundreds, thousands of messages per second. But then if you do long polling, then in long polling, you have like some limit that how many messages you can get. Let's say like you can get, with long polling, you can get 100 messages. But at that time you have like 1,000 messages. Then like there's 1,000 new message, but long polling it can return up to 100 messages with 1 request. And then what would happen is like you end up having n number of messages that you can never process. And then after 14 days, you will lose some of them. So it depends. So it's like depends.
In this case, short polling is
Best idea, but when you yeah, exactly. Okay, the key is it's something that you maintain. If your application has lots of transactions per second, then you would probably want short polling. If your application doesn't have many messages, then you can do long polling to save some cost. Okay, that's pretty much all. SNS, it's push model. So as she told us, like if you have one message, you want to process by 2 applications at the same time. For that you can use this Cirrus. And then you have publisher, and this is
it falls under asynchronous message bus model. That means there is something in between asynchronous. So we call it topic, and topic can publish the message to these 6 types of subscribers. It can be person, it can be human that you can connect with SMS and email, or it can be application A and B using this Lambda or Q or like some endpoints. So it's pushing that message. So if it's an endpoint, like if it's an endpoint of an application that's deployed behind A and B, then it can make call to that A or B, send that message. So it can send to application.
Professor,
Yes.
could you get to the previous one?
Hmm.
So in what case could we actually use the like the pushing any message to SQS? Because SQS is one-to-one, like point-to-point, right? But SMS is like publishing subscriber tools one-to-many. But I think, are we just like limiting the feature of the SMS in this case? What's the meaning of the SMS scenario?
Okay, I think real life case I can't think of it, but once she asked like what's your one of this? There is a queue. Okay, there's a queue, and you want to have 2 applications. I would say B and C. There's message 1, message 1. So what she asked is like, can we do this with queue? We cannot, but it looks like if you use SNS with SQS, then you can do this. So for example, here, okay, this is not a human, this is just event producer. Okay, anyway, so here, like some application sending message to this producer, and producer is sending message to, like we want to do things. We want to send these 2 messages at the same time. So for that we use SNS. So I use SNS for fan out, and this SNS can send to Q1 and Q2, and then application B subscribed to Q and application C subscribed to this Q. And what's following is your producer published a message, something called N1 messages in, and then that message is published to this queue at the same time. That's exactly what we're trying to achieve. And then that message is now consumed by this to consume. So this could be the use case. Like,
But yeah, but what I'm saying is, what is the point that we subscribe, but I push any message to SQS? Because SQS, it does point one-to-point, right? Which means even the topic could do directly with the destination we want. What is the point having SQS in the middle? But if it were like the other way around, it makes sense because the SQS can make only one point-to-point, so we can have topic in order to find out, right?
yes.
But what is the point having SQS in the middle of SNS and
Okay.
the other destination?
I can't think of any great example right now, but think of this way. SNS has these subscriber types, and one of them is SQS. It's just one of the features that SQS can subscribe to SNS. It's a feature. Just think of it. That's what okay, let's go back to here. Publisher, topic, subscriber. Okay, that's pretty much all. Let's do one hands-on. Maybe 2 hands-on. How tired are you? Tired
Scale of 10?
Scale of, yeah, scale of 10, how much? 11. Okay, then let's do this let's take a break. Okay, let's go lunch and some break. And after that, like we're done with this theory part. And now let's just take a look at how it's done in the console. That we are done with this. Like we achieved this figure. So yeah, I understand it's too much. That's why I gave 3 starting point in the first place. If you check it in syllabus, it's like one of those 2 heavy lists. And you are done with 90%. 90% you are done with this, and now just some hands-on. In the hands-on, like you would not notice these design patterns. You just send message, you receive, send message, you receive, and you never notice. But like I said, software developer, your technology stack has this SQS and SNS, and you just do as your team leads told you. But once you became a team lead or director or architect, then you need to choose your technology. Like when you choose your technology, you need to know like its patterns, like when to use it, or why we use it, right? As a developer, we don't care, we just use it, but when to grow unit, now that's.
So I have recording now. Yes. So I'll be back by 1.
Sure, yeah, about that.